Well, we want the area between two curves. So to do that, you're going to do the integral of the top curve minus the bottom curve. Well, why is that? Well, if you do the top y value minus the bottom y value, wouldn't you get the distance in between? And then you multiply by the little teeny tiny dx, the rectangle width, and you will get the area between the two curves. You will need the intersection of those two curves to integrate from and to. To find the area between those two curves, you will need to know where they intersect. For the most part, that will be the hardest part of some of these problems, is just being able to find the intersection. If it's a non-calculator problem. It's a calculator problem, let the calculator do that for you, right? So here's a graph showing what we're going to be looking for. The gray area here, and top minus bottom is going to give you this distance times the little width, the little dx, which is going to give you the width times the height. So when you add all those widths and heights up, remember an integral is just addition, so we're adding a ton of heights up. Yes, I can. Oh, right here. So this unit 7 is going to focus on area and volume, finding areas and volumes. So today, just area. On Monday, we'll start talking about volume. So in this example, the two functions are 2 cosine of pi over 4x and g of x equals x squared minus 4. The intersections happen at -2 and 2. X equals -2 and x equals 2. And so to find that particular area, it would be the integral from -2 to 2 cosine of pi x over 4 minus x squared minus 4. Make sure second curve is in parentheses, right? As always, if you're subtracting two functions, it would be the same way. And that's how you would find that area. Okay. Any questions? Good deal. Okay, so let's try an example. I want the area of the region between the graph of f and g in the first quadrant. What's the first thing, even if this is a by hand problem, that I'm going to have to think about? Where they intersect and what the graph looks like, because I need to know which one's the bottom one and which one's the top one, right? So whether I have a calculator or not, I've got to know that to be able to work this problem again. Sometimes that's the hardest part. So I'm going to look at a graph of x cubed without a calculator, because I know that one, right? And what else? I'm going to over dramatize that curve a little, zoom in on it, so my graph looks better. And what other line, or what other curve? Y equals x. All I really care about is the first quadrant. My first quadrant looks pretty good. Okay, any questions so far about the curve? So I'm looking for this area. I did need to know that x was greater than x cubed. Now you can try by plugging in a number like 1/4 cubed. 1/4 cubed is 1/64. So that's definitely smaller than 1/4. So the top curve is this one. The bottom curve is this one. So my formula is actually a little backwards for this particular problem, just because my top curve is g of x and my bottom curve is x cubed. Any questions so far? Yes?
If we happen to do it in the wrong order and showed up negative, can you
You could. Did everyone hear that? If you do it in the wrong order, you get a negative value for your area between the two curves. Then you would say, oops, I did it wrong. And you could fix it. So you could make that adjustment. It does, but it just says that if it didn't say that, you're right, we have to find more than one thing. We will do a problem like that. This is our first problem, but easy. So I'm going to do x minus x cubed. Everyone agreed? Top minus bottom. Where are the intersections? 0 and 1. Now you might just know that because it's x and x cubed, but how would you find out if you can just see it if we are doing a by hand problem? Set them equal to each other. You want to know when they intersect, so you can set them equal to each other. X equals x cubed. Get 0 on one side and factor. I noticed on the test, several of you try to solve these in all kinds of crazy ways. If it is above a quadratic and it has more than one term in it, you're going to have to get 0 on one side and factor for the most part. So x minus x cubed, or you should have done it the other way. Probably most of you would have rather done it the other way. That's all right. Go ahead. 1 minus x and 1 plus x. Now, that's a little more information than we need to know, right? Because the negative 1 is the intersection that we won't need to know for now. So 1 and negative 1 or 0 and 1 are the only intersections that we need to know for this particular problem. But setting them equal to each other does give us all intersections. You can tell that if this were on a test, it would probably be non-calculator because of the numbers. They're so pretty. Polynomial that I can do the antiderivative of.
If we fit on the other side, we would get negative area, right?
Mm-hmm. We did it backwards.
We don't need to know
to correct that. Yes. Now there are times you will need to know some things, and I'll show you on the next slide. So you won't always just be able to fix it later. But a lot of times you can. Good so far? What am I doing?
You're doing the
antiderivative. Good. I'm going to do the fundamental theorem, plug in 1, plug in 0. And I get 1/2 minus 4 minus 0. So the area between those two curves is a 4. As you're writing, just some leading thoughts. If you've ever seen a figure and wondered, if you needed to find the area of something that wasn't a rectangle or square or something that you could find an area of pretty easily, you now can see that if we could match a curve to the outside dimensions of the figure, we could find the area of anything using we've got a curve that would work. So this opens up being able to find an area of any shape, anytime. Doesn't matter what the figure looks like. You would want to put units if there were units given. You could put units squared if you wanted to, but it didn't give me any units. So.
What do they use this for?
So many things. For right now, it's only area, which you can see where you would want to find the area of things. But the extension of this is tomorrow we're going to start looking at volumes of solids that are not known sizes. And that is actually something in the real world I have used. My husband had a friend that was a construction company manager, and he called me and he had to find he was a bidder on a job, like he bid jobs. And they were doing this fancy thing out in front, like in concrete, and he needed to know how much concrete to bid. Well, most of the time they just make it a block. Just bid it and go, close enough, it's a little over, but it'll be fine. But he needed to get as close as he could so he could win the job bid. And so he called me and said, there any way to find the volume of this thing? Anything in dimensions, and we were able to find the volume using these practice sets. There are some places where and there are other things. You know how you have an equation for the volume of the sphere? Someone probably came up with that. Find an area of the region closed by the following two functions. Okay. So again, even if I don't have a calculator, I need a quick little sketch of these functions. If they're going to make you sketch, then they're going to be functions that you learned in Algebra 2 as functions to memorize. 2 minus x squared. Parabola moved up 2 units flipped. And y equals negative x. Doesn't have to be a perfect picture, just enough to see what's the top, what's the bottom. So we're going to integrate 2 minus x squared minus negative x. Are y'all okay if I just put plus x there? Minus negative x. Find the region that is a minus. What else do I need? The intersections. I'm going to find that. 2 minus x squared equals negative x. And what am I going to do?
X squared plus x squared.
It's 0 on one side, and I agree with Joseph. I'd probably move, even though there are 2 pieces over here, I'd probably move to the right to get that x squared to be positive. For factoring purposes, it's nicer if that x squared is positive. Questions so far? Oh, yeah, that's fine. Okay. Yeah. No, mine aren't things that are
Thousand cubes.
that have names.
100 by 100.
Okay, negative 1 to 2. Everyone agree? Question, y'all want to see me integrate that and do that, or would you rather just move on to more setup examples? We good with integration on that? Anti-differentiate 2x minus 1/3 x cubed plus 1/2 x squared from negative 1 to 2. Plug in negative 1, subtract. 4.5. If this is non-calculator on the real AP exam, plug in the 2, plug in the negative 1, leave subtraction in the middle, put parentheses and stop, move on your way. You don't have to get all the way up for it.
We don't actually have to. We just plug in the numbers and not do it.
Yes. But you have to plug in the numbers. You can't stop at this step.
Like
But,
that. Yep. One.
but you can do that. You can stop. That's great. If it's not calculated, do that. Because you'll mess up the addition. You won't get 4.5. You'll get something wrong. So, don't do it.
Miss King, can we do that? Can we do that on like your test, or do you want us just?
If it's non-calculator, yes. On the calculator, go ahead and plug it in. Make my life a little easier.
Okay.
You have a calculator. Yeah, but mine a pretty background, but up there it didn't translate like a bird. It's more like a salmon color or something over here.
Oh, it's actually kind of cinnamon. It's like a fresh.
Is that better?
It's like
you can see it now. That's what that matters. Computer screen colors don't always fit to picture screens. It was orange, but it was lighter. You can see it now. Yeah. Okay, before I start, I'm going to draw a picture. Everyone agree that's a good idea?
Yes.
Draw a picture. You don't want a lot to draw lots of pictures on these. Square root of x looks like that. X minus 2. Okay, then bounded it into the first quadrant, bounded above by the square root of x, below by the x-axis, and the line y equals x minus 2. So what is the region we're talking about?
wait. Oh, whoa.
All the way to that apple.
So it's
Which creates a problem. Why does that create a problem? If I just did the integral of square root of x minus 2, what area is it going to give me? It's going to give me the thing with the triangle, right? Now, of course, on this particular problem, you can do it and subtract the triangle off, but we need a little more information. How would we do it if we couldn't just subtract the triangle off? Okay, we're going to break this up into two different integrals. Okay, we're going to break this up into this piece. Why would I stop there? What's different from on the green part than the red part? It has a different top curve and bottom curve than the thing on the right, right? So I'm going to break this up into two separate pieces. Now I'm going to break this up. Okay, so I'm going to do the integral of the green part, which is just the integral of the square root of x, right? Everyone agree? Just the square root of x dx minus 0 if you want to write minus 0. It's just the integral of the square root of x. From 0 to 2, I did kind of shortcut that, but you heard Joseph say I found the x-intercept. I was just careful when I graphed to find the correct x-intercept. But so that equal to 0, add the 2 over, there's your 2. Any questions about that piece? The green piece gives me the green area. Plus, I need the red area, which is the integral from 2 to something. I don't know, we'll have to figure that out. Out of the square root of x minus 2. Now again, this particular problem, it wouldn't be a bad idea to find the whole area and subtract the triangle off. But again, we're learning what we would do if we could do that. What do I need on the top? What do I need up here? What goes up here? This thing, right? So I need that intersection. So I'm going to do the square root of x equals x minus 2. I do have to square both sides. Why is it not messy like that? I am foiled.
that shouldn't be x squared on the side.
You can all watch
Just square the square root.
And 0 equals x squared minus 5x plus 4. X minus 4, x minus 5. Right? Everyone agree?
X minus 4.
I mean, x minus 4, x minus 1.
Okay.
Okay.
I mean, I'm straight. Right there was another half of it. And so you got that other weird intersection that doesn't even exist. Okay. Okay. Any questions on this? I'm going to save the calculus. You can do that, right? X to the 1/2 power, add 1 to the power, multiply by 2. You can do it if you have to do it by hand. If you don't have to do it by hand, what do? Plug it in your calculator. Have y'all figured out how to use the integration button on the 89 yet? Okay, let's talk about it. Let's do that. Hi, Amy. Okay, go to F2. Home first. Always home first. Go home. And then go to F2 and go to integrate. Oh, so F3, sorry. I need to look. F3, go down to integrate. Type in the square root of x or x to the 1/2, comma x, comma 0, comma 2. Comma x, which is above the 9, right above the 9 is a comma. Comma x, comma 0, comma 2. That's the square root of it. Get close to parentheses. Don't close them until you get everything in. Okay. So it didn't get the comma x, comma 2. Point that.
I like my normal calculators.
You can use your normal calculator. Yes, you'll give me one. You did not need it yesterday on the test. F3, y'all watching? Everything that you need to do in the calculator, 84 can do on AB. Okay, F3 integrate. Square root of x. Comma x, comma 0, comma 2. Close parentheses. If you want to push enter and get an answer, you can. Or you can continue typing. Plus F3, the integral of the square root of x. Whoops, gotta find x. Minus x minus 2. Close parentheses. Comma x, comma 2, comma 4. Now, this calculator does not use pretty print when you're typing. It's a little more computer programmer-ish than the other one because it's meant for math majors, right? This is meant for Cal 2 and above, so why would you need it, right? They kind of figure you can figure out the commas, parentheses, and whatnot. But the good thing about it is it does put it in pretty print when you're done. So you do know if you type something wrong. You might not know how to type it, but you do know that you typed something wrong. Since I have this under here, I do want to show you one quick thing. If you go to your catalog and you go find something like if I push I can go down and find the integral thing. Integrate. You see that symbol? At the bottom, under catalog, when you're on something, it tells you how to type it in. It says, y'all listening? Listening? Even though you can't see this, I went to the catalog and I just put my cursor on integrate. Right at the bottom of the calculator, it says expression, comma variable, comma low, comma up. So what do you think that means? An expression, variable, A and B, right? So it's telling you what to type in. So if you ever want to use a button and you don't know how, that'll teach you how. So you can learn if you want to use the solve button, you don't know how yet, use that. It'll tell you. We'll work on the calculator more another day.
What is the difference between F3 integrate and F7 integrate? Wait, can I see that again in catalog?
Just go to your catalog and hover over one. 10/3. Did you go down to integrate?
Yeah.
Okay, let's look at the next problem. 10/3 was the answer to the last one. It looks like my text is going to integrate. So that's really next. I agree. Okay, everyone look at this next one. Find the area of the region bound by the following equation. This would be a calculator problem, I believe, because it's a cubic, right? You could find the intersections by hand. But most of the time in cubic, they're going to give you a picture or give you a calculator. So, find the area of the region bound by the following equation. What's the problem? There's which one, right? There's more than one region. So it's not a which one, it's all. If we want to find an area bounded by the two curves, there are two regions. But to do that, we will need to set up two separate integrals, agreed? Now, I did show you how to use the integral button in the TI-84. Could you have also done that last problem in the in the 89? Could you have also done that last problem in the 84? Yes. So, again, we're not to anything that the TI-84 can't do. Right? Alright, so I'm going to do the integral. Know with me? What is this first region?
That is good.
What am I going to do for that region?
Nothing. Because
This one? Right? This curve is on top. Everyone agree? So x cubed plus 2x squared minus 3x dx. I need to know those intersections. We all know how to find those in the calculator. I believe we can find these by hand pretty easily, but if you could do it in the calculator. So x cubed plus 2x squared minus 3x equals 0. Back out an x. And then x times x plus 3, x minus 1. So 0, negative 3, and 1. So would you agree negative 3 to 0 on this one? Again, if it's a calculator problem, you do not have to find those intersections by hand. If it's a calculator problem. Plus this area, which is what? From 0 to 1 of 3x minus, do I need these parentheses here? Very much so, right? X cubed, run out of room.
when in doubt,
Yes.
parentheses.
Okay. Any questions about that one? Now, maybe on the AP exam, maybe they give you the picture and make you do this non-calculator. It is possible non-calculator, but again, I'm going to focus on setup because I have some more problems I want to set up. You can do integrals. We hope. If not, you need to come take that mastery test some more. Use a calculator to find the area of the region. I'm going to skip this one for now. Okay. Okay. So let's look at this one. It is y squared minus 2. X equals y squared minus 2. Okay. In minus negative square root of x plus 2. Or if you're really on top of your game, you can just do this area and double it. You've got options. But then I'd have to do this integral as well. I would have to find that intersection, right? Nothing wrong with it. Just pay attention to that. If the top curve is different or the bottom curve is different as you go along, you have to use multiple integrals. However, just changing the thought up a little. Say that again. We would have to do that area. Here. Here, because it's not bounded by. This is open. What's the word bounded? Between. It's not between. No, you're not. That's a good question. Okay, so I would have to do top curve minus bottom curve. So the top curve here is this positive square root of x plus 2. Well, I have to get y by itself. Y, I mean, we don't normally deal with that, right? So you have to get y by itself. And that does bring up two curves, which does make sense. This really is two functions. But I'm not going to do this problem this way. You can do it this way if you want to. It's always an option. You can always break up into multiple integrals if necessary. We did that on the last couple problems ago, right? However, what is x? It's y. If x be y, if y be x. I guess it be y. Turn it this way. Right is positive, left is negative, so we'll keep it going, right? So, if I look at this as a y set of curves instead of x, as I look at it of y, is the top curve the same the whole time? The right-hand curve is the same the whole time, right? And then the left-hand curve is the same the whole time. So I'm going to change it up a little. Could you do it this way? Yes. Is it going to be easier this way? Yes. So I have this right-hand curve. Now it is x cubed, but if I'm going to work with y, I do need to change that to be what? Almost. Would it truly be y cubed? Cube root of y. So I do need to solve for x, just like if I were doing it the other way, I would have to solve for y. So the right-hand curve is the cube root of y. The left-hand curve, I'm going to go back where x is already by itself. Notice they kind of set it up to do it that way, didn't they? Yep, x by itself. Right, because I now want to work with y instead of x.
And we're just switching house.
So we're going to do Okay, so I have a few questions. Couple of answers to those questions. Ready? How do I get my calculator to do this? You can either plug in 3 equations, all in terms of x, and then find the y values, right? That would be the typical way most of you would want to do it. Or you could stick with the y equations and just call it x in your calculator. However, if you do that, then you will be looking for the x value because you call it yx. And that's okay too. You have options. When someone finds an extra, give it to Annalise or me. Okay, I do want you to do as much of it. What do you think? And 1.793. Really quick. Really quick. If the area is bounded on the top and bottom, use the formula top minus bottom. Bounded on the left and right, use right minus left, dy. From y value to y value. So really quick, this one I would have used top minus bottom. Does everyone agree? This one, I could go either way, whichever one's easiest. Does everyone agree? Does everyone see that? This one I would do right minus left. Why?
Is this supposed to say volumes of solids?
No, is that what I get?
Yeah.
Over